Introduction of the study. Nowadays, noise pollution is proven major impact of human health and job efficiency currently in several studies and research. So research show traffic noise in Jalan Kluang-Johor has increased dramatically since the turn of the century, owing mostly to increasing transportation of people and goods. The traffic noise is defined as any unpleasant sound produced by vehicle while driving on public roads. So this noise is caused by the engine and frictional contact between the vehicle and the ground, and is influenced by traffic flow rate, so which is determined by vehicle speed, so and road surface quality. As a result, evaluating traffic noise level in residential areas will aid in understanding the state of noise pollution and the environment.
I will continue about the methodology about this project. This topic will outline the study method used to collect traffic noise statistics in Jalan Kluang-Batu Pahat facing off the UTHM campus Padat Raja. The data was collected for 2 days of 3 hours for each day. We are using this application for collecting the data. For calculating the data, we need to determine the mean, median, mode for each day. Following that, the variance and standard deviation also should be calculated. This is the equation to calculate variance and standard deviation. There are 5 summaries of the set of data in box whisker plot, which is minimum, first quartile, second quartile, third quartile, and maximums. To assess whether the data contain outlier or not, the upper and lower inoffense value must be calculated. For the inference statistic, the test for difference between the two sample mean are using the equation for n is greater than 30. For the f-test, we are using the two population variance method, which is f is equal to s1 power of 2 over s2 power of 2.
Siti Atikah. Now we proceed with calculation for chapter 1. On the right is data for day 1, while on the left is data for day 2. These are the manual calculations for day 1. Firstly, we need to calculate the x minus x bar, and then we square the values. So lastly, we get the values for x minus x bar square is 2006.303. Next, we calculate mean, mode, Q1, median, Q3, interquartile range, lower limit, upper limit, variance and standard deviation. So for mean, we get 60.936, while mode, we get 61.3, which is 61.3 is the most frequent observation in the data, and the first quartile is 52.35, while the median is 61.3, which is 61.3 is the middle value where the data is arranged, and then the third quartile is 68.325, while the interquartile range, we minus the third quartile with the first quartile, then we get 15.975. The lower limit, we get 28.3875. Upper limit, we get 62.2875. While variance, we get 57.32. And then the standard deviation, we get 7.57. Next, we proceed with manual calculations for day 2. It is the same process as day 1, which is, firstly, we need to calculate the x minus x bar, and then we square the values, and then we sum up. Okay, then the total of summation of x minus x bar square is 803.9675. For me, we get 54.842. The mode, we get 56.9. The first quartile, we get 49.15. The median is 57. The third quartile is 58.45. The interquartile range is 9.3. The lower limit is 35.2. Upper limit is 72.5. While variance, we get 22.971, while for standard deviation is 4.792. For frequency distribution curve, we change the data from ungrouped to group data, which both days have interval classes of noise readings. For day 1 have 5 interval class, while for day 2 have 4 interval class. Next, we continue with box and whiskers plot. On the first picture, it shows that 50.1 is the minimum value, while 52.35 is the first quartile, 61.3 is the median, 68.325 is the third quartile, while 72.5 is the maximum value. Besides it shows that the data for day 1 has no outliers, since the maximum and minimum value is within the upper fence and lower fence. Next is for day 2. Day 2 it shows that 47.1 is the minimum value, while 49.15 in the first quartile, the median is 57, while the third quartile is 48.45, and the maximum value is 61.1. And for day 2, it is the same as day 1, which is it has no outliers, since the maximum and minimum value is within the upper bands and lower bands.
Okay, thank you to Aimi Najla. I will move to the calculation for significant testings. Because of the two difference of mean, the two sample hypothesis testing were chosen in this calculation. The table 3.3 shows the important detail for calculation two sample hypothesis, which is have the value of sample mean, standard deviations, sample size, and value of significant level. So, the first step, we need to make a hypothesis for hash null and hash alternative. So, the hash null is the value of mean, same with day 1 and day 2. Meanwhile, the hypothesis for hash alternative is the mean between day 1 and day 2 are significantly different. The second step is put the value of significant level. Because of the hypothesis is two-tailed test, so the significant level will become 0.025. After that, we need to identify the test static. Because of the sample data n is more than 30 with no standard deviation, the equation normal distribution population will use to find the value of z-test. From the equations, we get the value of z-test is 4.077. The next step, to find the value of z-critical, we need to refer z-table. Therefore, the level of significance is 0.05 with two-tailed test, then we will get 0.025 level of significance for upper and lower tail. To know the probability, half of the graph 0.5 need to minus with 0.025 and then we will get 0.4750. From that, just refer the z table and find the value of 0.4750. We will get z critical is 1.96. Since the z-test 4.077 more than z-critical 1.96, we will reject hash null and conclude that at the 0.05 level of significance, there is sufficient evidence where the sample day 1 has a significantly different mean with sample day 2. That's all from me. I will give to Nurmizatul Aneesa to continue the analysis of variance.
Next, I will proceed to the analysis of variance, which is the manual calculation for f-test 2 sample of variance. So, the null hypothesis is the variance of the sample 1 is equal to the variance of the sample 2, and the alternative hypothesis is the variance of the sample 1 is not equal to the variance of the sample 2. The value of the variance for the sample 1 is 57.32, and the value of the variance for the sample 2 is 22.97107143. The degree of freedom for both days is the same, which is 35. The significant level alpha is 0.05. Because of the test is the two-tailed test, the alpha was divided by 2 and we get the alpha value is 0.025. For the f value, by using the interpolation method from the critical f table, the critical f value that we get is 1.9755. So as shown in the figure, this is the table for the alpha 0.025. The values that have been circled, which is 2.0735, 1.9429, 2.0089 and 1.8752 was taken and was calculated by using the interpolation method to get the f critical value. For the f ratio, we get the value is 2.495. Based on the figure of the two-tailed test, the f value is greater than critical f value, which is 2.495 is greater than 1.9755. Therefore, the null hypothesis being rejected and can be concluded that at the 0.05 level of significance, there is sufficient evidence to suggest that sample day 1 has a significantly different variance to the sample day 2. This is the software data for the f-test. The variance observations, the degree of freedom and the f value is the same with the manual calculations, but the f critical is slightly different with the manual, which is 1.961089, but both of the values from the manual calculations and the software data for the f critical still give the same result and conclude that we still reject HO, which is the null hypothesis.
Next, I will talk about the discussion about this study. This is the comparison value between day 1 and day 2. We can see that the value of mean, mode, median, variance and standard deviation for day 1 is higher than day 2. This is due to the fact that the number of vehicles on day 1 is higher than day 2, because the day 1 is a working day while day 2 is a holiday. Box whiskers, the result indicate that there are no outlier in the data of the 2 days. The frequency distribution curve on day 1 demonstrate that the distribution data is most clustered on the left. Therefore, the distribution is skewed to the right. The distribution data for day 2 show that the most of the data was grouped on the right. That means the distribution was skewed to the left.
In conclusion, the study had assessed traffic noise in 2 days. Traffic hours and noise index data were collected and then analyzed according to the project needs. A box and whiskers plot can manage and display a vast quality of data. So the median, which is the middle of the data range, the upper and lower quartiles, which reflect the numbers above and below the highest and lowest quarters of the data, and the minimum and maximum data value comprise a box plot. Using 5 key concepts to organize data in a box plot is an efficient way of dealing with a large amount of data that are too large or for other graphs, such as line plots or stem and leaf plots. It can be handy for quickly summarizing and comprising several sets of findings from various trials. Several mitigations can be taken to reduce exposure to environmental noise, such as recutting a class that has potential receive less noise than a class near the roadside. And then we can plant trees that can absorb noise and thus reduce the noise level received, and conceivable noise reduction and existing roads, such as building soundproof barrier between the road and buildings such as a school. Thank you.